So question 1 from paper 2 of the additional assessment. And this question is all about moments and the principle of moments. So we're given a diagram where we have a wheelie bin that is tilted to one side. And if you've helped out in your own homes by moving the wheelie bin around, you'll have some familiarity with this situation and the forces involved. So we've got G marked on with the weight acting from there. Because the weight is acting through point G, then this is the centre of gravity. You could have put centre of mass, which would have also got you the mark. Then we are told that the mass of the bin is 23 kilograms. It's a bin, so we're on planet Earth. So what's the weight of the bin? Well, the weight is its mass times G. Remember, the weight is a force. So the mass was 23. G on planet Earth is approximately equal to 10. So we get 230 newtons. State the principle of moments. The principle of moments, you are required to be able to recall that the sum of the clockwise moments are equal to the sum of the anti-clockwise moments. Excuse me. And that's to be in equilibrium. So to be in equilibrium, the sum of the clockwise moments must be equal to the sum of the anti-clockwise moments. There were other ways of expressing this less well. So one or two of the ones I marked answered this, but didn't quite say the sum of. It really needs to be the sum of all of the clockwise moments and the sum of all the anti-clockwise moments to get the mark. A person applies a force. So we were given this on both pages, so you can see the diagram and you can answer it. It's all the same question. So person applies a force at F. G is acting downwards. So the weight is beyond the pivot. So if I were to let go, it would fall over. So the person applying a force F, and that force will be upwards. So they're holding it upwards to counteract the downwards force of the weight. So calculate the magnitude of force F. So look at the diagram. Force F is at 98 centimetres from the pivot, and the weight is at 37 centimetres from the pivot. So the thing we've just stated about the sum of the moments, so the clockwise moments, so weight is giving us a clockwise moment. So the clockwise moment, I'll call cm, so that's the force times distance clockwise. So I'll use c's. And then the anti-clockwise moments is the force anti-clockwise times the distance from the pivot anti-clockwise. So then I've got the weight, which I've just found out is 230 newtons multiplied by 37 centimetres. For this one, I can leave them all in centimetres if I choose, or I can convert them into metres. I think I will convert them into metres, but if you let it in centimetres, it's still valid. And then this is the thing we're trying to find, times that distance, which is 0.98. So now I just need to find what 230 times 0.37 all divided by 0.98 is. I'm going to need my calculator. So 230 times 0.37 divided by 0.98 gives me 86.8367, and lots of other numbers. In terms of this, I'm given 2 sig fig throughout the question, so I'm going to give it to 2 sig fig. So 87 newtons. State the magnitude and direction of the force applied to the person by the bin. This is, take some careful reading. I had to read it quite carefully a few times, so I'm trying to work out what on earth's going on. To the person by the bin. So this is checking you understand Newton's third law. It's checking that you understand that if the person applies a force of 87 newtons on the bin, then the bin applies the same force in the opposite direction on the person. So the person is pulling up on the bins with 87 newtons. So the bin is pushing down on the person with 87 newtons.